All right, so elements of Java. Okay, so classes, variables, data types. Okay, we all know what a variable is from like math, right? X equals 0, right? But in math, x can only equal a number, right? In Java, x can equal anything. It can equal it can equal a word. It can equal a number. It can equal a um, person, a person object. So in Java, this is where things get interesting. Okay, so let's talk about the first concept, which is a class. Okay, and I've been mentioning classes for a while now, but I haven't really explained what a class is to you guys. Cool. Okay, this is a really important concept. This is a foundational concept, right? When it comes to Java, if you don't know what a class is, you can't say that you know what Java is. Okay. A class is a template or blueprint, okay, which holds the properties and functions and defines how an object of that class is made. That's what a blueprint does, right? It tells you how to make that object, right? Um, okay, so writing a class is called implementing a class, right? That was the keyword that we used earlier, right? Implementing a class. Um, Objects are instantiated from the class, or the object is an instance of the class. So, again, I already showed you guys earlier, but right, you have a class called person, right? And when you instantiate that, you are creating a tangible object or tangible person, right, from this blueprint that we have here in the class, right? Now, depending on what we have in the class, we can change the property when this object is created, right? So, for example, like let's say in the class person, I said like, like the person has green hair, right? That's my blueprint. So now every time I create a new person, he's going to have green hair, right? So that's kind of the relationship between a class and an instance. Right? Here's the thing, though: we can create many instances of class. We can play God. When I create, when you in this, yeah, I put these terms missing. Instantiate a class, right? This is what you're doing. You're reading this and you're creating a person out of it. So we'll talk about how you can set the properties and things like that inside the class later. But for now, let's just say that the class is a blueprint, okay? And you instantiate, right, objects from that class, okay? And those instances, right, or objects, right, are the things that we will be interacting with, right? You don't interact with the blueprint. You interact with the object, right, that's created from that blueprint. Does that make sense? So that's a very important concept. Do not mix up class and instance, okay? Class and instance are different concepts, right? Okay, conventionally named like an everyday object. Object, okay? Object-oriented programming, okay? That's why we call it object-oriented programming, because every class models an object. Okay? Consists of, okay, every class consists of these three things, okay? Variables, methods, constructors. Okay, I'm not going to really talk about what they are right now, okay? But let's just say for now that variables are kind of the properties that the class would have. So, for example, an example of a variable inside a person class might be something like hair color, right? Defines the characteristics and properties of an instance of that class, or what an instance of that class might be, right? So certain properties of a person class might be something like what? Name, hair color, eye color, things that define what an instance of that class should be, right? Does that make sense? Yeah. Okay. Methods defines what that instance should be able to do, right? What should a person be able to do? Okay. If I have no methods inside my class, that person cannot physically do anything. Okay. If I have a method like that says like take a shit, then all of a sudden my person now has the functionality to take a dump, right? Constructors. Okay, the constructor. We're not going to talk about that right now. That's in another lecture. But these two are actually not even this one. We're going to cover these variables today, so we'll go over these soon. Okay. Okay, Java classes continued. Okay, so now let's talk about how to create a class. Okay, and we're going to do a live demo in a second here, but first, let's talk about this format right here. So this is a modifier. Okay, a modifier is public, private, protected, default. Okay, if you do not, okay, if you look at this example on line 1, he does not have a modifier here. Okay, he just leaves it blank. Okay, and honestly, that's probably what you're going to do most of the time. Okay, and it defaults. If you leave nothing, it defaults to. Oh, okay. Yeah. If you write default, these are basically the same thing. Default. Okay. Private, protected. We're not going to really talk about protected, but actually, no, let's talk about it. Let's talk about protected. I think we'll have to. Okay, so class, okay? Visibility and scope. Okay, we're talking about visibility and scope, right? So modifiers deal with visibility and scope. Okay, so visibility means something you can see or access something, right? Because you can see it, and or something you can't see it, you can't access it. Okay, so let's say we have two classes. Okay, person and classroom. Now, what's the relationship between classroom and person? The classroom has many people. That would be the relationship, right? Okay, so let's say this is a public class. Okay, so this classroom, because this is public, right? This classroom has access to the blueprint on how to create a person. So if you want to create a person inside this class, you can just look here and say, okay, well, I already have the blueprint. You can create a person. Okay? That's public. That's what we call visibility. He is able to see the blueprint. He is able to see the class. Okay? So he can create a person. He can do whatever he wants with that person, right? Now, if it's private, pretty self-explanatory. You cannot see it. Right? You can't see the blueprint. He's not able to create it. Okay, protected is, when we talk about protected, we need to talk about the structure of our programs or our Java projects. Okay. When we create new Java projects in Eclipse, right? And this is our IDE, right? In the left-hand corner, we have a little Java project, right, with a J here. And we have one that's in Hello World, right? Right? Those are Java projects. And then inside here, what do we have? We had a folder called the Java project has a folder that contains the source code, source, and inside the source, what do we have? Yeah, our Java file, right? Okay, but actually, inside the source file, it's actually organized by what we call packages. Okay? So this would be like, I think it's a move for packages now. And when you just add a class or a Java file to the source file, it puts it in the default package. And you can actually define multiple packages. Right? Let's say like number 2. Okay? So if you have multiple Java files right here, 1, 2, 3, you have one that's into so 1, 2, 3, 4, 5, 6, right? You have 6 Java files under the same Java project, right? Protected means classes within the same package, they kind of see each other. Does that make sense? So the visibility is restricted to the package that they're located in. The visibility is restricted to the print package that they're in. So this guy cannot see anyone from this guy. He cannot, any of these files cannot see anything from this print. Does that make sense? Honestly, you won't be really using that one, so that's why I was kind of hesitant to explain that one, but I guess it's good to know. So public means anyone can see. Private means, nobody can see, and then we're going to use the modifiers for more than just the classes. Variables also have modifiers. Okay, so right here, classroom. Okay, and this is what we call the scope of the class right here. See where this opening bracket is? Right here. Okay, this is the closing bracket. Anything within those two brackets is what we say within the scope of the class. Okay, does that make sense? So that's kind of how we use the word scope. Okay, so if anything is outside of those brackets, then it's not part of the class. The class has no it's not part of the class. Okay. So same thing right here. You'll see that we have methods right here. Okay, and we haven't really talked about what methods are, but notice it also has a bracket and a closing bracket, and anything in between those two brackets are part of that method. Does that make sense?
Should explain a little bit the relationship between class and what we're doing this the public static void.
Okay, so that's an example of a method. Okay.
That's a method.
Yeah, that's a method. Public static void main is a method. It's a special type of method, but it's still a method. And it's kind of confusing because there's a lot of words like preceding that, right? Like public static void main, right? But honestly, those terms we'll kind of discuss once we get to that lecture, which should be tomorrow. Okay. So, but for now, let's just note that these are what we call methods. Okay. And the scope of these methods is shown here by this opening bracket and this closing bracket. So anything within that scope is part of the method. Okay. So when that method is called, that's the code within these brackets that gets run. Yeah, that's where it goes. So the class, remember, contains methods and variables, right? So these are variables right here. And what do you notice about these variables in relation to the word classroom? Room number, total seats, total rooms. They are all what of the classroom? Huh? Yeah, okay, yeah, they're all private, right? These are not parameters because we're not doing a function here, right? They are properties, right? Notice, right? Classroom. Every classroom should be able to know what their room number is, right? If I instantiated an object of this class, I created a classroom, okay? A tangible object, right? And I asked the classroom, hey, what's your room number? It should be able to give me back a value, right? Same thing with total seats, right? What's your total seats? It should be able to give me a number. Same thing with total rooms. How many rooms, total rooms? What's your total rooms? What's the value of your total rooms? And it should be able to spit back a value to me, right? So we need to initialize those values when we create a classroom, okay? And we're going to talk about how we can do that tomorrow, okay? So,
explain why you call it private. Instance variables, you always have private.
Why is it private? Because that instance variable should only belong to that class. So why would it make sense to make it public for any other class to see, right? That private variable should only belong to that class. No other class should be able to change.
So if you do a subclass, then
subclassing? Okay, we haven't talked about subclassing yet. But that's actually the next slide. So, okay, yeah. So let's just say for now, I just wanted you guys to show you guys what the basic structure of a class would look like, right? We have the classroom, right? With a modifier, there's obviously no modifier here, right? And then the scope of the classroom starts from here, goes to here, and it has 1, 2, 3, 4 methods, 4 things that classroom can do, right? And it has 3 properties: room number, total seats, and total rooms. Okay? That's the basic idea that I wanted to get across, okay? Okay, next one. So let's go ahead and create a class, okay? And so I want you guys all to open up Eclipse, okay? Okay, so now that we have Eclipse running, let's go ahead and create another Java project, okay? So new, so you can right-click, new Java project, okay? And let's call this creating classes. Okay. Go ahead, click finish. Okay. This is where we're gonna practice creating classes, obviously. Okay. So in the source file, the first thing we need to do is go ahead and create a class. Okay, and that is synonymous with a Java file, right? So right here, class. It says class, right? That's all we need to do. And remember, the convention for naming classes is that number one, the first letter is capitalized, right? And that they are named after everyday objects, right? Don't name it something like XYZ123. Like that makes no sense. That's not an object that we would interact with in the real world, right? Name it something like, person, or whatever object you want to create. So let's go ahead and create a person. So I'm going to create a person. Okay. And let's go ahead and click this top button. And what that's going to do is it's going to basically add one method into our. It's going to add a method into our person class. Okay, but it'll just be blank. So that method will be there, but it will do nothing. Okay. So there we go. So this is our method, right? So this is called a comment when you use those two backslashes. And it doesn't affect the code at all. It's just for your own reference. Okay. Okay. Class person. Okay. That's it. We created a class. Okay. You'll notice that if this was a blueprint, right? And I said create me a person, what is that person going to look like right now? It has no properties. It has no functions. But if I instantiate a person right now, it'd basically be a blank. It'd be like nothing, right? It has no properties. It has no functions. Okay. So right now our blueprint is empty. But that's okay. We're gonna add to that more later. Okay. So let's go back to the slides here. Let's talk about inheritance. Now this is a very big. This is one of the 4 main main topics. Or if someone asks you what object-oriented programming is, there's a simple answer, and the simple answer consists of 4 terms. Okay, inheritance is one of them. Okay, we're not going to cover the next 3 right now. That's for later on. But inheritance is one of 4 of the major components of object-oriented programming. So it's very important. Okay, so inheritance is the idea that a superclass, right, gives all of its properties to one of its subclasses. Okay? Now, this is the example, the most popular example, and it's a good one. Okay? Vehicle. Okay? Vehicle is the superclass, right? And can you guys think of some subclasses for vehicle? Okay, let's do a little bit more. Let's come up with 3, and let's make them more generic. Truck, more generic. Well, I guess we can. Is car more generic than truck? I don't know. That's the whole point, right? That's the whole point of inheritance. Is the car is a vehicle, but so is a boat. And so is a plane, right? These are all vehicles, right? Now, what's the commonality between all 3 of these things? That a vehicle. Okay, first of all, what should every vehicle be able to do? What's the whole point of a vehicle? Move, right? Move. It moves you from one place to another, right? So this right here has move functionality. Okay. Now the idea of inheritance is that every class below vehicle should be able to do what every vehicle should be able to do. So, is that true for this? Yes. A car should be able to move, a boat is able to move, and a plane is able to move, right? What other functions or properties of the vehicle are there? This vehicle is a very broad term, right? It's hard to pin one property to a very big term like this, right? What about steer? Vehicle should be able to steer, right? Okay. The reason why I put those parentheses is because anybody might. Okay. Again, subclasses. They all are able to move and steer. Okay. So the idea of inheritance is if the superclass has it, then the subclass has it too. That's like, okay? But it's not necessarily the other way around. Okay. Just because a car has it doesn't mean a vehicle has it. Okay. Right? For example, can you say that every vehicle has tires? No. Right? But a car has tires. Right? Has tires. Right? So when we're talking about vehicles, we don't ever say a vehicle has tires. Right? So here's the idea, right? This is the idea that I want to convey. And I'm going to say it I'm going to repeat it one more time. Every property that a vehicle has, or a superclass has, all its subclasses should have. Okay? It does not reciprocate. Okay? Meaning, just because it works that way doesn't mean it works the other way around too. Okay? Car has tires, right? The vehicle does not have tires. Okay? That's inheritance in a nutshell. Okay. So we say in this model, we say that we should be using these solid lines. The correct notation for this is actually dotted lines, and it means that when a certain class is a subclass of a superclass, we say that car extends vehicle or the subclass, right, extends the superclass. Okay? So I'm going to go over this demo that's going to show you exactly how inheritance works. Okay? Let's extend the superclass. Okay, so let's go back into Java. And oh shoot, okay, I made the same mistake yesterday this morning. But okay, so we're gonna scrap the person class. We're not gonna scrap it. Let's just leave it. Okay. Instead, let's go ahead and create a new class. Okay, and we're gonna model the example that I just put up on the board. Okay. So vehicle, we need the superclass first, right? Let's create the superclass. Okay. Let's click finish. Okay. There's our vehicle. Let's create another one for car, which should be a subclass, right? Car, right? And let's create one more that's called boat. Okay. So we have vehicle, car, boat. Okay. And let's close this for now. Okay. So here's what I'm going to do. I'm going to write a method inside the vehicle class, and I'm going to call it move. Okay. And inside that method, what I'm going to have it do is I'm going to have it print the word the vehicle moved. Okay. Now, if the vehicle class has a function called move, right? And then inside my car and boat class, I extend vehicle, then both the car class and the boat class should have what? The move method, right? Does that make sense to everybody? So by writing one function only in the vehicle class, right, I'm able to kind of like pull it down into the into the subclass just by using the extends vehicle keyword or the extends keyword with the superclass. Okay, so I'm going to show you guys exactly how we can extend the vehicle class. Okay, so the car class keyword at the top of class, we're going to write extends vehicle. That sets up the relationship. Okay, now I've told the Java program that car is a subclass of vehicle. That's what that extends does. Okay. Same thing with boat, right? Extends vehicle. Actually, you know what? Let's do this. Let's. I'm curious to see what this will do. Let's go ahead and delete this boat Java. Okay. And let me write down on the board what I'm thinking. Okay. Subclasses, right? Because inheritance works on multiple levels, not just one, right? So we only went one level down, right? What I'm going to try to do is this. What's the type of car? Honda? SUV. Okay, SUV. It's the type of car, right? Okay. That extends that. So if this extends that, then that means this extends that, right? So if vehicle has a move, then car should have a move. And if car should have a move, then SUV, right? We're going to take it 2 levels down. Does that make sense? 2 levels down. What I mean by that? Okay. So let's create the SUV class. Okay. SUV. Okay, and the SUV extends the car class. Right? Is anyone stuck? No? You guys are all good? Okay, so here's what I have. I have vehicle, right? Obviously, vehicle doesn't extend anything. Vehicle is the top level, right? Car extends the vehicle, and the SUV extends the car class. Okay? So the next thing I'm going to do is go ahead and write a void move method. Okay? That's a function. Okay? The word void just means that the method is not going to return anything, but it will print something. Okay? So the next thing I want you guys to do is write this system. And this is how you print something to the console, right? Out.println. It's a really long command for something really simple as something simple as printing, but you just have to memorize it, okay? And let's say the vehicle has moved. Okay? Does that make sense? Okay, so now that we've done this car class should have the move method, but where is it in this class? It's automatically public. So the car extends vehicle, it should have the move method. Where is it? Why isn't it in my class? If I should have the move method. Well, it's not written in the class. How can I call the move method? Where is it? I know, but like I don't have any method called move inside my class car. Right here, right? So how does it get pulled down from the parent? Exactly. It gets pulled down by the extends vehicle. So I don't have to write another move method inside here because it's almost like I have like an invisible. It's like I have an invisible exact same thing, right? It's like I copy and pasted this entire thing in here, right? Except this is like invisible, right? Does that make sense? What I mean by invisible, right? It's there, but we don't actually have to write it in our car class for our class to have that function, right? So that's the good thing about extends. right? It lets us write less code. Does that make sense? Because imagine if we had one superclass that had a move method, and we had 100 subclasses, right? Now instead of having to write a move method for all 100, all we have to write is extends vehicle for every single one, and they automatically have move, right? But that's only the case if the vehicle has only one method. Imagine if vehicle had 10 methods, right? Now you just saved so much time because now for every single 100, instead of having to write those 10 methods for every single method, you only have to write extends vehicle, and you automatically have the vehicle's methods. Does that make sense? That's a very, very big concept in object-oriented programming, okay? And so that's what we call inheritance, okay? So if SUV extends car, then that means SUV also has the move method, okay? So the next thing that I'm going to do is I'm going to go ahead and create another Java file, okay? And this Java file is just a very generic file, and we're going to use this file to start creating some objects, okay? So let's call it this tester, okay? Okay, and in the tester class, we're going to write a main method, okay? So try going, so public static void main, okay, string args. Okay. If you guys are on Eclipse, another shortcut you can do is this. Go ahead and type main, okay, and then click Control space. It should autocomplete to what this is right now. Did that work for any of you guys? Did that work? So once you have main, so write main here, and then click Control space. I don't have it enabled on my Eclipse for some reason, so it doesn't work for me. But since you guys just installed it, it should work for you guys. So scroll through those options and choose the one that looks like this. You see? Okay. All right, so we have our tester class. Okay, this is a main method, right? So let's, you don't have to write this, but this is a main method. So just very vaguely, okay, a main method makes a class executable, okay? What that means is that I can now run this class, okay? And when I run this class, it's gonna do exactly what is in the main method, okay? So if I do a system out print right here, so the snippet for system out is this, okay? So just do that and then control space. This out. Okay? Okay. Let's print this is a test. Okay. Did everyone get that? You have to enclose the this is a test into double quotes. Okay. Now if I run the tester, okay, if I click the green button on the tester class, okay, the first thing it's going to look for is the main method. Once it finds the main method, it's going to go into the main method and start going line by line and executing everything inside the main method. Does that make sense? Okay, so click the green button for tester, and it's going to say this is a test. Okay, so now let's get into the fun stuff. Okay, this is where it gets fun. Okay, now instantiation or no. Instantiation, yes. I always get these confused. Instantiation is when you create an instance of a certain class, right? Let's go ahead and create an instance of the car class, okay? So how do we do that? I'm going to show you guys right now. Car, this is the name for the instance, my car, is equal to new car. That right there created a new instance of a car, okay? Now, what did we say that car has? Or no, well, according to this blueprint. No, well, what is the class? What does the class have? What is it able to do right now? It doesn't say it in the class, but it inherited a move method, right? So why don't we go ahead and call the move method? And the way that we call instance's method, okay, is called dot notation. I'm going to show you what that is right now. My car dot, that's why it's called dot notation. And you'll notice that when I click the dot, it shows me a list of all the things that I can do, right? Notice this move method. You can click that, and that's it. Okay? Now, what does the move method do? Let's go back and look at the vehicle class. It prints out the vehicle has moved, right? This is defined in the vehicle class. We don't have it in the car class, right? So let's go back to the tester and let's run this and see what happens, okay? The first thing it's going to do is it's going to see this line and say, okay, I need to instantiate a new object of the car class and name it my car, okay? The next thing it's going to do is it's going to say, get the instance my car and call the move method that it has, right? So I ran it and it prints out the vehicle has moved. Okay? Pretty cool, right? Yeah. So that was the first example of creating an object and calling that object's function. Okay, we haven't really mentioned what a function is or like how it applies, right? But the main idea here is that we're implementing inheritance, right? And nowhere in this car class is there a move method. It inherited it from its parent's vehicle, right? Okay, next up, let's go ahead and, okay, so car has a move method, right? How about this? Let's add a method inside the car class. Call it void. How about steer? Okay, okay, just like that. Okay, steer, and it had, let's do a system.outprint. Let's say the car has steered. Okay. Now, where does the steer function exist? Does it exist in the vehicle class? Does the vehicle class have the method steer in it? Why not? Exactly. It's not the superclass, right? Remember, we said everything flows downwards, but it doesn't go back up, right? Does that make sense what I mean by flow down, right? All of vehicles' properties flow downwards, right? But if a subclass has a method, that doesn't mean that the superclass has that method, right? But if it flows down, and SUV is the subclass of car, what methods are inside SUV now? Oops. Move and steer, right? Because it takes the method from its superclass car and its superclass vehicle. So now it has both, even though we have nothing in this class. Okay, so let's go ahead, create a new SUV. Okay, I'm gonna leave that up to you guys. Okay, how do you create a new SUV? I mean, it's gonna be the exact same way you create the car, right? Except the names are gonna be different, right? Instead of car class, it's now SUV class, right? And you can choose the name to whatever you want the name to be, right? So go ahead and make a new SUV. Once you've done that, let me know, okay? And we still got about 2 hours left, so wait, hold on. Wait, is that right? Yes, we still have 2 hours. Okay, yeah, we still got a lot of time then. Let's take a break after this part, okay? So let's create a SUV object. Let's instantiate an SUV object. Okay, so I'm gonna show you guys how to do that right now. SUV called, you can call this name whatever. You can honestly call it X, but that would be a bad naming convention, right? We want to name it something descriptive of what that thing object actually is, right? So my SUV, or I don't know. Okay, honestly, I don't know how this naming convention is because it's like all capitals. So let's just say it's that, okay? Equals new SUV, boom, boom. I have a new SUV object, right? Now, what do you think I'm going to do next? Okay.
That's what I was asking. What do you want to do?
Yeah, well, what do you think I'm going to do next? You tell me. What do you think I'm going to do next? I'm going to call its two functions, right, to see if they actually work, right? So my SUV, right, it should also have move, right? So that's what we were just talking about, right? So let's go ahead and test the move, right? And then let's also call the my SUV, dot what? Here. Okay? And it should have both of these things, okay? So the thing is, okay, so let's go ahead and run that and see what happens. Okay, what's the expected output? No, what three things am I going to see in the console down here? What's it going to say? Yes, right? Does everyone understand why that would be the output? Yes. Or public means not, it means the entire project, right? Protected means only package. Okay, see this default package? You can have multiple packages here, right? So I can create a new. No, I'm honestly not sure why you would have different packages. Maybe if you have like a really, really big project, you would separate it up into packages with different visibilities, right? Like, for example, like maybe one package might be like a feature or something. I don't know. I'm not exactly sure. I haven't really made Java projects that big, but I'm assuming that's what it would be for, right? You would, because okay, but imagine if you had 100 Java files, you know?
Yeah, but that's what I was asking. Like, it's only working the same package at the cost.
Depends on what modifier you use, remember? If you use a public modifier like here, it doesn't matter what package it is. If it's in the same project, any class will be able to access this tester class, right? If I put this to protected, okay, then only other classes within that package will be able to use this tester class, right? Okay, so yeah, we ran it. The vehicle has moved. That was from here, right? The second vehicle has moved is from here, and then the car is steered is from there. Okay. So that's inheritance. Okay. Created the superclass, the subclass, and the subclass. Right. You see how we like created a method here, added an additional method on top of that, and then this one inherits both of them. Okay, that's the main idea. Okay. One more concept that I want to talk to you guys about is what we call an abstract class. Okay? And plainly speaking, or just to make things simple, I didn't understand what an abstract class was until too late, you know? And you guys are really getting a good deal here. I'm basically explaining to you guys all the things that I've learned, you know, not from school that you guys have to know, right? So, okay, abstract class. Write this one down, okay? Abstract class. Abstract. An abstract class, let me give you the definition first, okay, is a class that is too generic, too vague, too instantiate. Too vague, too instantiate. Oh, right? It's too vague. Okay? And I'll give you the example of that, okay? Let's say I said, Steve, make me a vehicle. Can you do that? Exactly. It's too vague. A vehicle could be a boat, it could be a car, it could be a plane, right? That's an example of an abstract class. Okay? I'll give you another one. There's a class in Java called the object class. If you have, create me an object. Too abstract, right? Too generic. Needs to be more specific, right? Create me a circle. Okay, I'll give you the circle. That's not an abstract class. Does that make sense? You just keep the way you do it. What do you mean? You created an object class, right? Vehicle's an object class, right? But you cannot make an instance of that class, right? I cannot do this. You won't let me. Because just like I said, if I ask you how to create me a vehicle, can you do that?
But for example, like, and you just say like you don't have all the subclasses, like
because it's too vague, right? It's going to say you cannot instantiate abstract classes.
So the question is like, what did you learn? Like if someone said, "Oh, create this car," automatically you know. You said like you do like fix, like go around it. You said you do 50 hours to realize abstract.
Oh, I didn't understand what abstract meant because no one explained it to me. Right? Like they went over it, they kind of gave me a definition of it. But honestly, you know the example where I just gave you where I was like, give me essentially a vehicle, and you're like, I don't know how. If someone just said that to me one time, I would understand the abstract concept. But O'Brien never said it to me. So yeah. So that's an abstract class, okay? That's the basic concept, okay? That's the concept, okay? Okay. Now, is that everything I want to cover for inheritance? Implements is different.
So I feel like that was it's been like a while. So I see there's like a super dot like dot super. Like they used to call that some of these class. But like what do you use it in
Okay, so the super keyword, okay?
So I didn't really understand like what you guys were
Yeah. Okay, so we'll actually go over that not today, maybe in the future, because should we do that? I feel like it might take a little bit too much time, because then I'd have to give you a completely new example. So okay, so let's talk about variables. A variable, we've all seen it before, but in Java, variables are a lot more complicated and they have a lot more functionalities, right, than in a math equation, okay? So x is equal to 10, but instead of x, we can give it a name, like we've seen so far, right? And again, there's naming conventions when you create these variables, right? For example, that total seat starts with a lowercase t, right here, right? And then has an uppercase s, right? Okay. And okay, so that's why I put this here. You can't use these reserved names, okay? These are special keywords, okay? So if you try to name a variable one of these keywords, it will give you an error, okay? So just don't use that. That's just a side note, okay? Okay, so variables represent the state of the class, okay? So let's go back to this example up here, okay? Right here. These are three variables, okay? Room number, total seats, and room total are the names of three variables, okay? And what it means by that the variables represent the state of a class is that it holds the values that an instance of a class should always know. Okay, so read that one more time. This means that it holds values that an instance of a class should always know. Not the class itself, but every instance, right?
You gotta post these slides.
Yeah, I will post these slides. Okay, so going on. So there are different types of variables, and we're going to learn. There's essentially well for now we're only going to go over two. Okay, but what does it mean that it holds a value that an instance of class should always know? Like if you, so for example, well actually you know what, that's not necessarily true. Let's actually go to the next slide, and then we'll talk about the two types of variables. Okay. Okay, it's actually this slide that I want to get to. So let's just have a vague understanding of what a variable is. Okay, it's basically a name for a value. Okay, a name that stores some sort of value, right? But like I said, we can give it a name instead of just x or y. Okay, and usually these names have to be kind of more descriptive of what it holds. Does that make sense? So if I create a person, right, and I create a variable, right, that points to that person, I don't want to call that variable something like xxy. because when I read that variable name, it tells me nothing about the type of data that it stores. It stores a person, right? So my variable name should be something like my new person or something like that. And it tells me that the name, just by reading the name, I can tell, oh, this probably stores a value of some type of person. Okay, so choosing names are very important. Okay. So Steve, I just gave basically a very simple definition of what a variable is. It's a name that stores a certain type of data, right? And we want to choose those names appropriately, right? Like, for example, if that variable holds a person object, we don't want to call that variable name like my box, right? Obviously, because it's not a box. We call it something like my person, right? Because it holds, it holds a person, right? So the names are important. So make sure when you guys write variables that you guys get in the good habit of writing good variable names. Intuitive names, okay? You guys know what intuitive means? Intuitive? Intuitive means it's easy for someone else to understand. Because that's the whole point of your code, right? It's not like you're going to be writing. It's not like when you work for a company, it's not, your code is for other people to read, not for you, right? So think of it as a contribution to someone else, right? If you write messy code that's not intuitive, then it's going to be hard for other people to, Java docs, yeah, I really didn't use it. Huh? Oh, the comments, yeah. Honestly, yeah. So that's another thing. So when you write clean code, right? I mean, it's honestly those are all just style points, right? But style points are important, right? It's like if you were going to speak Japanese, right? Either you can speak Japanese with an American accent, like arigato, or you can actually say it with like a smooth Japanese accent, right? You know what I'm talking about? That's the difference between writing bad code and good code. It's like, it's just so easy to understand if someone speaks to you in fluent Japanese, but if they're speaking with a bad accent, you're like, wait, what? Wait, what?
It's like return person thing. Because they say like there's extra style points that you just like a double slash with return.
Yeah, or something like that. Yeah, so just like, comments help, variable names, good variable names help, things like that. So JavaDoc is, one of them. I'm not going to actually go over JavaDoc for this course because I don't think it's too important. And if you did want to learn JavaDoc, you could learn it in like 10 minutes, to be honest. So, yeah. Okay, data types. Now, the difference between the variables that you guys are used to and the variables in Java are that variables in Java can hold other things besides just numbers. Okay? Like for example, when we created this variable, right here, we called it my car, right? What does that hold?
A new car.
It holds a car instance, right? That is a data type, right? And that's the data type that we created, right? We created it right here, right? So, so there's two types of data types here. The first one is going to be a primitive data type, and there's only 8 primitive data types, okay? And they're up there, okay? Boolean, byte, short, char. This means basically character, okay? Short for character. Integer, float, double, long, okay? So, if I want a Boolean, let's start with Boolean. Boolean is, let's say, is done, okay, is equal to, that's my variable name, right? So the data type is always here, then the variable name, and then equal sign, and then the dot, right? So Boolean is either true or false. Okay? No quotations around those two words, okay? Next one is, we're not going to go over byte short, but we are going to go over char. Okay? My char equal to, okay, the way you create a char, single quote, right? Char, my char equals single quote a single quote.
just try it, but like we also use it. I think there's like two ways, but she didn't really say like this really complicated. Okay, you can also use like substring.
Yeah, so we'll go over some of those right now in a second, okay? So integer, I don't know, total students is equal to 1. I'm going to actually do this on Eclipse here. Okay. Might just be easier for you guys to type it and see it. Okay. So we have a Boolean here. Okay. So let's do let's inside the SUV class. Let's make some variables inside the SUV class. Okay. So we did int. Okay. So total, let's say seats is equal to 4. Okay. Here's our variable. Total seats is equal to 4. Okay. Let's say we want. Okay, we're gonna actually skip float as well. It's not as common of a data type. Double is basically, so integer is any whole number, right? Negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doubles are decimals, right? 1.0 is a double. It's basically 1, right? But it has the 0.0, right? So 1.2, negative 1.2, 0.5, these are all doubles. Okay? Does that make sense? The conversion between integers and doubles is kind of complicated. Honestly, if you're going to use ints, you should usually just use ints. If you're going to use doubles, you should just stick with using doubles. It just makes your life easier if you can. If you can't, then you're going to have to deal with conversions, which I'm not really going to cover, because if you wanted to, you can just Google how to convert from int to double. And it'll show you in like 5 seconds. Okay. But I am going to let you know that that is not possible. Okay, or that's not. Sometimes it's not possible to convert from int to double, and sometimes not from double to int. Okay. I feel like actually I'm not sure about that. I feel like it would be, you wouldn't be able to convert a double to an int, but I think you would be able to convert an int to a double, because you can just, if the integer is 1, you could just convert it to a double by putting a dot 0, right? I feel like. So I'm not sure. I'm still not even sure, but
I know that's easier to do like double to an int, but I don't know to get to a double. It's double to an int, they just like rounded off the decimal.
I don't know. I'm actually not sure. But honestly, if I wanted to know, I could Google it and it would tell me in a couple of seconds. So I'm not worried about that. If you guys run into that problem, honestly, just Google it. Just know that all you have to know right now is that converting from between a double and int might be tricky. Okay, so if you ever get an error because you're trying to convert those two, just Google it, and it should be easy to fix. Okay. Double. Let's say my percent increase or whatever. Okay, it's equal to 0.90. Okay. I'm gonna give you another example. My double. Okay. What do you know it's about that? It's an int, but why doesn't it give me an error? Yeah. So even though I passed an int, if I were to print my double, the value, it would print out 9.0. Okay. So in this sense, that's an int to double conversion. Okay. And I think it's the IDE. The IDE is smart enough to do that for you. Okay. Okay. Double. Looks like that's all we want to do right now. Let's go over some of the cool things you can do with initializing these values. Okay. Let's say 4. Now this is where it gets kind of cool. The total integer would equal 8, right? What about this? What would that equal? Spacing doesn't really matter. 5, right? Order of operations applies, right? First we do the 4 divided by 4, which is 1. Then we add 4, right? What about this? -1. Right? 4 plus 1 minus 6. Right? How about this? What's that?
Zero. Oh, no, that's 1.
It's 1. Right? Now what happens if I do this?
No, you can do that.
What did I do? Sorry, 1 second. Huh? What was that? So yeah, that's the question I was going to ask you guys. So total seats. What can I update the variable? Okay, hold on. So I need to do this inside the main method. So hold on. Okay, that's another cool thing you guys can do. Okay, if you highlight all of these and press tab, it'll tab everything together. But if it's too far tabbed, you can do shift tab and it'll bring it back. I'm not sure. Okay, anyways, total seats now. Let's say I update total seats and I do plus plus. Okay. Now that plus plus at the end of the total seats, what that does is it increases the value of total seats by 1, right? Because it's an integer. So what is the value of total integer here? So once we run this main program, okay, what's the value of this total seats? Somebody want to answer? Okay, so I'm going to repeat that one more time. So this is what we call declaring a variable, okay? And you can do this. It just means that there's going to be no value attached to that variable at the time, right? This is what we call declaring a variable. When we initialize a variable, you guys see the difference? So I'm going to do that one more time. So this is declaring a variable, okay? This is initializing the variable, giving it an initial value. Does that make sense? So, it's a good question. Sometimes you need to declare it first before you initialize it. And I have a perfect example, but we haven't gotten to that point yet. So let's put that on the back burner for now. Okay, and I'll show you in the future. I'll show you tomorrow basically why you might not want to initialize it to begin with. Okay, there's certain situations when you might not want to. Okay. All right, so we've learned that you can use operators to compute, values and store that value into another integer. Okay. Now the reason why I don't put an int before this one is because this is already an existing variable, total seats. See how when I click it, it shows me where I initialized it, right? So if I were to do this, that would be telling the IDE that I want to create another variable called total seats, but that's not what I want to do. I want to use a pre-existing total seats and just add 1 to it, okay? So if you are updating, you don't need the int data type in the front. Does that make sense? So I have one slide that I'm going to go over now. I'm going to show you guys kind of what I mean. Okay. So okay. Let's go over some of these first. Okay, so yeah, updating a variable, right? Remember, left side is being assigned, right side is the value you want to assign it to. So let's take a look at some of these examples. Int total seats, that's declaring it, right? Equals 60. So once after we declare it, then, oh yeah, initializing it, right? Then we don't need to call the int anymore. We can just call the variable name itself. And if we want to update it to 99, we can go ahead and do that, right? If we want to add 1 to it, we can just do plus plus. That's one special operator that is kind of useful, okay? Plus plus. Another one is decrement it by 1. That's minus minus, okay? So some things you might want to memorize. Okay, this one is kind of a special operator, and it means add 1 to itself, right? So itself plus 1, okay? This right now is exactly the same as this, is it not? So let's say total. So the current value of total seats at this time is what? It's 99 here, right? So then we go here and we say 99 plus equals 1, right? So that's the equivalent. That's the equivalent
It's total seats equals total seats plus 1.
of, yeah, total seats equals total seats plus 1. But it's just a shorter way of saying that, okay? So this is essentially the same as this, is it not? Right? But if I put 9 here, you can't do that with this one, right? This one's specifically only for incrementing it by 1 or decrementing it by 1. Okay? Does that make sense? So same thing for this one. It's equivalent to total seats is equal to total seats minus whatever the value is here. So minus 10, right? So minus 10, right? Again, you can do operations to compute the number that you want to put in here. Okay? And remember, any of these values here are replaceable by variables, right? So you can use other variables in place of these numbers, and the value of the value of the variable that you use will be used in this equation. Does that make sense? Did that make sense, Daniela? Yeah. So in this equation, we use the number 60, right? An equivalent statement would be, for example, if I created another variable, okay, and I called it value, okay, and I gave it the value 60, okay, so I said int value equals 60, okay, and I replaced 60 with value. That would be equivalent, right? Because previously we had 60, right, and the value of this variable called value is also 60, so that would be the same, right? So we can substitute in variables inside these equations, okay? And so that's basically what I did here. So I made total seats equal to the current value of room number. That's exactly the example that I just said, right? So if I initialize room number to be 100, then that means in this statement, total seats would be equal to 100, right? Easy enough, right? Okay. So we have about an hour left. Okay. Let's go over the main types that you should know, okay? Boolean int. Oh, actually, we didn't go over the second type of data type. Okay, the second type of data type is a non-primitive. Okay, no, float is a primitive. The top ones up there are right here. These ones are primitive, right? There's only 8 of them. I'll explain it right now. Primitive means basic, right? That's basically what the definition of primitive means, right? Non-primitive means a little bit more advanced. Okay, so the primitive ones are the basic ones. Non-primitive is basically every other type. Okay, so if in our example, right, we created this car class, right? And in our tester, we created this car. We instantiated a new object, and we stored the value in my car, right? Right? Do you see this? My car. My car is a variable, right? It's a non-primitive data type because its data type is type car, right? Does that make sense to everybody? Okay, so a non-primitive type is basically any other type besides a primitive type. If it's not a primitive type, it's non-primitive, okay? So if I ask you what's the type of this car, what would it be?
What is the class that you define another class?
Yeah, it's a class, but it's also the data type in this case, right? Because that's, like I said, a variable, right? Or the data type tells you what type of object that the variable stores, right? Yeah, for example, a string, right? So if I created like a string name equals Michael, right? That Michael, what is it? It's a string, right? So the data type is called string. That's why we see string name equals Michael, right? In this case, right, we have a car object, right? So that variable is pointing to a car. So the data type is car. Same thing here, right? We have SUV. So you can actually create your own data types if you create your own classes. Does that make sense? Okay. A very common one. Okay, so those are user-created classes, right? Those two examples I just gave you, car and SUV, are data types that we created, right? However, in the Java API, how many of you guys know what a Java API is?
Application programming interface.
Okay, yeah. Okay, it's basically a set of documents that tell you all the tools that are available to you that Java provides to you. Okay.
But I thought API is more like it's like a waiter on a restaurant. Like you're the customer. Like you tell the waiter to do something, the waiter takes the system. Like they return you a result.
Yeah. Okay. Well, the API documentation, right? I'm not going to go too much into detail right now, but let's just say Java, okay, has built a lot of these classes for you already. Okay. For example, car. Okay. Java already has a class called object that it already wrote. The people who created Java, they pretty much went ahead and they created all these classes that they thought people, are going to need in the future. Things like string, right? String is already a class that the Java creators, created beforehand.
So
and
primitive,
no.
That's not.
Okay, once again, primitive is one of only those 8 data types. If it is not one of those 8, then it is not a primitive data type. Okay, it has to be one of those 8. Everything else is non-primitive. Okay, so string class, non-primitive. Okay. So string class is an example of a pre-made class that the Java creators just made, right? Okay. So the difference is how it's stored in memory. I'm actually not going to go over that right now. I don't know if we're going to have time for that. If we have time, then I'll come back to it. Okay. So let's go over these again. Boolean, true or false. Those are the 2 values that it's going to have. Okay. Notice the true and the false are not enclosed in any type of quotation. Okay. Got it? Integer example 0, 1, -47. Okay. You can initialize a variable by doing order of operations here. Okay. We already went over that. Double is a real number, 3.14, blah, blah, blah. You can also do math to compute the value of a variable. Okay. And so, okay, string. This one's a very popular class and something that you definitely have to know, okay? So, main types you should definitely know, right? String is a very popular one, okay? Any program that deals with any type of text, you're going to be using string. So I would say if it's not the most popular one, then it's the second most popular one. Okay? So, or most used, I should say. Okay. So get familiar with it. Okay. This right here, string name is equal to Michael plus hy. That is an example of concatenation. Remember that common term that I mentioned earlier? Concatenation. It means combining 2 strings together and making it 1 string. Okay, so the results in Michael And because I didn't actually add a space, it's actually going to result to that. Right? Spaces are included, right? And I did not include a space at the end of Michael or at the beginning of H. So if I combine them, there's no space. That's one common pitfall, right? So make sure you either have a space, or if you don't want a space, then just don't put a space, okay? That is concatenation right there, okay? String second name. This is another example of concatenation, but using a variable, right, instead of the actual literal string, okay? Does that make sense? So this would be Michael adds un to Michael H, because this is the value of this variable called name, right? So that's string concatenation, okay? Pretty simple. It's a very common tool that they use, okay? This is not add, okay? It's not like the integer add. It's completely different, okay? When you use this plus sign between two strings, it's concatenation. It's completely different. It's not addition, okay? It's concatenation. Okay, now, this string class, okay? Actually, let's do this. I'm gonna do it on Eclipse so that you can see it here, okay? So let's go ahead and do this. I want to create a new string. And I'm going to call it Michael. Okay. Here's my string. Okay. Everybody see that? Now, that's my string. The string class, okay, has a lot of pre-built methods. Okay. How do I know what methods exist for the string class? So for our car class, right here, see how we created a car, right? How did we know that there was a move function? Yeah, but it's because we created it that we knew there was a move function, right? But the creators of Java made the string class. So how do I know what methods are available to me if I have a string? Documentation, okay? So what we're going to do is we're going to go here. We're going to go string class Java, okay? And you see this? This is what's called documentation, okay? Now, in this documentation, it tells you all of the variables and all of the methods that are contained within the string class that the Java creators put in there, right? So if we go ahead and go down, this tells you what all the constructors, all the different types of constructors that it has. Okay, this is really advanced, okay? There's multiple constructors here. We're not going to talk about those are yet, okay? Methods. Now, these are all the methods, right? And it has a description of what every single one does, right? So I'm going to go down to this method called substring. Okay, let's read the description of this. What do you think, just from the definition of, or the term substring, what do you think this method's going to do? Yeah, or given a string, it's going to take only a range of that string, right? And do something with it, right? Okay, so this is returns a new string that is a substring of this string. Okay, so let's see how we can use that. And right here, parameters. Okay, remember, given a function, we need certain other information to finish that function. So in this sense, the beginning index. Okay, so we're going to talk about what that means. Okay, so in a string, okay, every letter in a string is given a number. It's like a position in line. Okay, and it's called an index, and it starts at 0. Okay, so M has the index 0. Okay, I has the index 1, 2, 3, 4, 5, 6. Right? Does that make sense? So the index of L is 6, and the index of M is 0. Okay? So that's what this is asking for here, the substring. It says begin index, right? That's how it's going to tell you That's how it's going to find the correct substring, right? Because you're going to give it the index, right? So if I want just AEL, right? A is index 4, right? L is index 6. So I just give it right here. The begin index, I'll put in 4, and the end index, I'll put in, okay, 6. This is where it gets a little tricky, okay? Let's try 6, okay? Let's try 6 and see what happens, okay? So let's do this. But here's the thing. This function, we're not going to talk about too much right now because this is tomorrow's topic, but it returns a new string, okay? So we need to store that string in another variable, okay? So call it string. New string, okay, we'll call it new string is equal to name dot substring, okay? And we want to get get just AEL, right? So let's go ahead and put 4 because that's the index of where A is, right? Does that make sense, everybody, so far? Yes. Does it make sense why I chose 4? Daniela? Yeah. Do you understand why I'm choosing this number 4? Where I got this 4 from? Oh, yeah. No, that's what I'm saying. Okay. So, like I said, this string, it gives numbers for the position of every character in the string, right? So, M would be position 0. So it's given this index 0, right? Yeah. I would be 2, C would be 3, and then A would be 4, right? 5 would be E, and L would be 6, right?
I have a question. So it's so weird to me. Because I used different idea before, then so what I usually do, I do like string name equals new string. Then I say string name, a name equals Michael. But then like, oh wait, I think I know.
Okay, so let's go on. So there's 2 types of methods we can do here. So there's one called substring, and it takes only 1 parameter, okay? And there's another method called substring, but it takes 2 parameters, okay? So we're going to use the substring method that takes 2 parameters, okay? So by putting 4 here, we're going to put 6 here, okay? So hopefully what this is going to do is it's going to read this name string, okay? And it's going to take the substring of that string from position 4 to 6 and store that new string in this variable called new string. Does that make sense? Yeah. Yes. Okay. Let's see what this value is. Okay. I'm going to comment these out so that they don't print anything. Okay. Let's go ahead and run this program and see what happens. Okay. What is going on?
Oh.
What's going on? Okay. AE, right? Why is that? Because this is 4, this is 5, this is 6. So if you were to read the documentation correctly, what it would tell you is this number, the index of this number is included, meaning the number at 4, or the letter at index 4 is included. So it includes A. But if you read the documentation correctly, it would tell you that this number, at this number, it does not include this number. So it's everything up till that number, but not the index 6. So it will not include index 6. So let's try going up another, let's go up one more, right? And see what happens then. Now what do we have? AEL. So we got the correct substring now, right? So this method right here is a very popular one, and one that you're going to be using a lot. So this is just the basics of how to use the substring.
In this case, why was that M 0? Why did it start
It's just a convention. Yeah, convention meaning that's just the standard. That's how it is. Okay.
Yeah. Our class is the same.
No, yeah, no, it's the same for Java everywhere. Okay, the index always starts at 0. Okay, memorize that because that applies for everything. Okay, arrays too, array lists too in the future. Everything starts from 0 in Java. Okay, when you count, it's 0, 1, 2, 3. Never, it's not 1, 2, 3. Java, it's 0, 1, 2, 3. Okay. Okay, cool. All right, so now that was how you create. That's how you right because. So what I just showed you is how to find methods of certain classes that you haven't made, right? The string class we didn't make, right? But I just showed you how you can find methods of a certain class, that we have not made, right? The creators of Java made this class, right? And in order for us to find out what methods exist in that class, we need to look at their documentation, and that's how you do it, okay? So let me just review. So what I did is I typed in the class name here, string, and I just put Java, okay? Or string class Java. And that took me to this page here, right? Where it tells me all the constructors, all the methods. And this is the big part right here, right? So based on what you need to do, just scroll through here, find the method that corresponds to what you're trying to do, and you can go ahead and use it, okay? All right. We have about 40 minutes left, so let's get back to the lecture here. So that was data types, right? Because we ended like 9:35ish, or I don't know, 9:45. Okay. Okay, so that's strings. Okay, strings have multiple methods. That was only one of. You guys saw that list of methods, right? That was only one method. So, in terms of the foundation, so like I was saying before, this course is only going to teach you the foundation, right? I'm teaching you how to find those methods, but it's up to you to go ahead and look through those methods and learn how to use each of those methods. I'm not going to sit here and walk you through every single method that is in that string class, okay? Because honestly, there's thousands of classes like that in Java, so I cannot sit here and go through every single method with you, okay? That's up to you. That's what I mean by self-taught, okay? And the way that you can self-teach yourself is by reading through that documentation, okay? All right. Okay, so again, primitive, non-primitive, right? What's the difference? Primitive is those 8, non-primitive is any other one, any other type, okay? All right, so yeah, creating a variable, this is the generic way of, or the standard of creating a variable. First, you have a modifier, right? Either private, public, protected default, right? You have a data type, which is either a primitive or non-primitive, right? And then you have the name of the variable, okay? Remember, naming conventions apply, right? Lowercase and then uppercase, uppercase, uppercase. And then you have the value or the object, right? Okay, so let's look at this example real quick. Private string first name Michael. Notice the double quotes. That makes it a string. Okay, the double quotes makes it a string. Even if this was a number, if I had double quotes around it, it would still be a string, even though it's a number. Does that make sense? That's important to note. Okay, so even if I put this number inside these double quotes, it would still be a string. Okay. So if I did double quotes 1, 2, 3, 4, 5, 6, 7, 8, 9 double quotes, that is a string, not an integer. Okay. Public integer number of chairs equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Literal value. That's a literal value, right? Same thing here. Integer number of students is equal to 6. I do not have a modifier, so it defaults to public. Okay. Integer number of students, not initialized, but it is declared. Right? We did declare the variable, we just haven't given it a value. Right? Char, my letter, notice single quotes. Okay? Single quotes for characters. Okay? And then lastly, double, my number is 10.0, literal value, right? Okay? So that one's pretty easy one. So the last, I think I only have, okay, yeah.
Can you go back to that slide real quick?
Which one?
Creating a new variable.
So that's creating a new variable, okay? So took me a little bit longer to get through this lecture than the morning class, but we still have some time to do some practice at the end of this class, so I'm trying to wrap this up now. There's only like one big concept that I want to cover with you guys next, okay? And it's a very important one, so with the rest of the energy that you have, I'm already brain dead, so let's, okay. Let's cover this really quickly. Okay, conversion. Converting from one type to another type, okay? Let's say you went ahead and you created, okay, so this one right here, this is the error, right? Because you're trying to create a string, but you put in a 5. That's an int. You can't store an int in a data type that's string, right? So it's going to give you an error, okay? If I put double quotes around that 5, that'd be okay. That'd be a 5, but it'd be a string, right? It'd be the string letter 5, right? Okay. This, however, right here is a method of the integer class, okay, that takes a parameter, right? You pass in an integer that you want to convert to a string, and this method will spit out a string and store it in this 5 variable here, okay? So it's just a special type of method, okay? That's what it's designed to do, okay? Another way of doing it is you can concatenate, okay? See this? What is this? You can tell me what that is.
I don't know. It's just an empty string.
It's an empty string, okay? So it's a string, but it's just, there's nothing in it, okay? But it's still a string. And if you happen to add some type to it, like an integer like this, what it will do is that it'll actually do a concatenation. Even though it's an integer, it'll concatenate the two, right? So convert this 5 actually to this. Does that make sense? That's a useful trick. So if you have an integer, if you're given an integer and you're like, shoot, I need to make this a string, you can go ahead and do it like this. Okay? This works with variable names too, right? So if you put a variable here,
yeah,
that would also work as well, right? Okay, string to int. This is error because you can't store a string in an int. Okay, that's pretty simple, right? But you can do this. You call the integer .parseInt. Okay.
What is parse?
Parse again means to break a bigger piece into smaller pieces, right?
But it's to,
so what it's going to do is it's going to look at the string that you pass and find the integer within that string. Okay, it's going to cut it out and say, I'm converting this into a, you know, it basically looks through the string and recognizes where the integer is, cuts that piece out, and then converts that to an integer and then stores it in this foo. Okay. Now, if you put in hello here, that would be an error. You can't even, you're right. This only works if the string has numbers in it, right? Does that make sense? If I put hello, there's no way you can convert hello to an integer and store in here. It has to already be a number, okay? All right. Okay, I'm just going to go over this really quickly since we're running out of time. Heap is used for containing the actual objects. Stacks are using for storing less important things like the name of the variable. So when you declare a variable, right, you're storing the declared variable name in the stack. But when you give that thing a value, you're holding the object or the value in the heap. Okay, 2 different types of memory. Okay, both of them which are located in your RAM. Okay, you guys know what RAM is?
yeah.
Yeah. So it's RAM. RAM? Do you know what RAM is?
I think just generally like it random.
Okay, I'm just gonna give you a very generic explanation. RAM is quick access memory, okay, and hard disk drive is.
Oh, you mean that RAM? Okay.
Yeah. Okay, so this would be stored in the stack, right? This would be stored in the stack. This would be stored in the heap. This would be stored in the stack. This car object would be stored in the heap. Okay. We already went over updating a variable. Okay. Okay, this is pretty much this slide, and then this slide should only take like a couple minutes. Okay. This slide is the most important slide about variables, okay? Because there's two types of variables. Those two types of variables are, number one, instance variables, okay? Instance. Where have we heard the word instance? Okay? Yeah, instantiate, okay? Instance basically means object, right? It means instance, right? It belongs to the instance, okay? So an instance variable, okay? And then the second one is called a local variable, okay? Here's the difference. An instance variable is persisted, okay? Persisted means it doesn't get destroyed, okay? An instance variable is persisted when you create the object. When you create an object from the blueprint, right? So you instantiate an object, okay? And it retains its instance variables, okay? So we'll do a quick demo before class ends today, so I can show you guys what I mean by that. Okay, and they're usually private and they are static. Okay, I should actually add that here. Okay, and then why are they private? An instance variable you can think of as almost like a property of a certain class. So, like I said, when you have a class called person, what's an example of an instance variable? Think properties.
Eyes, nose.
Okay, eye color, height, name. These are all types of properties that you might want to persist, right? When you create an object, a person object, those are types of variables that you don't want to get rid of, right? Does that make sense? Because every person should have a value for their name. Every person should have a value for their eye color, hair color, right? Height. These are all things that should be defined when you create an instance of a person, right? Okay. So that's what I mean by persistent, right? At no point can that instance variable be deleted from that instance, right? It's not like you can just be like, okay, you don't have a name anymore. No, you can't do that, right? So these are persisted. That's what I mean by persisted, okay? A local variable is a variable that's only really used once. It's maybe like for a computation, and then you can just throw it away. You don't really need it anymore. Okay, so that's kind of used within methods. So we'll go over that in a little bit. So maintain state within the method only. Once the method is over, the variable is pretty much unaccessible, or it's thrown away. You don't need it anymore, right? It's only used to do like a small computation within the method, and then once that method's over, then you don't need it. It's thrown away. Okay. So this brings me back to the topic of of scope. Okay. Scope is remember. So the scope of an instance variable, okay, is the entire class, meaning anybody in the class, anything in that class can access an instance variable and get its value. Okay, so right here we have an example right here, right? Right here we have a method called setRoomNumber, and what it's doing is there's only one line of code, right? And it's pretty much updating room number, which is a instance variable up here, right? And it's updating it to this new value here. Okay, let's just say it was 60. Okay, not RN. Okay. That's just making it a little bit more confusing. Let's just say it updates it to 60, okay? So this method is able to see the room number and update it within this method, right? Because it's an instance variable, okay? There's actually no example on here of a local variable. Well, actually, these are local variables, but these are also parameters, so I don't really want to go over that too much. Okay, so local variables are public. It doesn't really matter because once the method's over, it's going to be gone anyways. So it doesn't matter what it is, right? Okay, and then static variables are always accessible, and they belong. Okay, so use the static modifier, right? So a static variable belongs to the class. Okay, and I'm going to explain what that means in a little bit. Okay, so let's move on, and we're going to do the demo for this in a little bit, but we only have about 20, 30 minutes here. So I want to go through the demo because the demo is going to show you more than what I can explain. Okay, a constant. Let's just do this really quickly. That's how you declare a constant. Okay, public static final int pi value equals something. Okay. Now, what's the definition of a constant? What's the difference? Never changes. Okay. Constant by definition means never changing, right? And we can assure that it doesn't change by using this keyword here, final. Okay. If you use this keyword final when declaring a variable, if you try to update that variable, it'll throw an error. Okay. So that's how you make sure that that value is never changed. Because it's for like this example, like pi. Why would the value of pi ever need to change? It shouldn't, right? So you declare it as final. Okay. Conventionally uses all caps as and undercases or all caps as underscores. Okay, that tells you that's a constant. Okay, does that make sense? Same scope as an instance variable. It can be used within the entire class. You can also, I guess, you can create a local constant, but maybe I should delete that. It could be a local variable, I guess. Okay, more of a design thing for readability. Okay, because you can always create a variable with the exact same value, and you don't honestly have to declare it as final as long as you just make sure you don't update it, right? So the final is just kind of like a safeguard, right? In case somebody does try to change it, it'll throw an error right away, right? So technically, final, you don't really need it, but it's like, okay. That is it for today's lecture. We're going to spend let's take a quick 3-minute break, and then I'm going to show you guys on demo. It's going to make a lot more sense once I demo this thing, how exactly these instance variables work. Okay, cool. All right, so I'm going to pause the video real quick. Okay, so now we're going to go ahead and do the demo section. So we are going to essentially, in this class person that we made earlier, design a person with different properties and different initial values for those properties, okay? So let's talk about some instance variables that a class person might have. But it needs to have a value. Like head boolean true.
Head equals
1. What would that mean though? That doesn't really make sense.
You have one head.
Maybe number of heads. But then when would that ever change? Would you want to give the person 3 heads?
Age. Sometimes.
I mean, I guess.
Only on Wednesdays.
I mean, you could. I mean, I guess you could have an instance variable that tells you that says something like number of heads, and set the value to 3. I guess if you want, but that wouldn't really be a person in that case. Okay, let's try name. Let's start it off simple. Okay, private. Okay, static. String name equal to Michael. I want Michael. You can put whatever you want. Okay. Let's do the same thing for. Okay, how about you each give me a property? Age. Okay. Private static. Okay, what's the data type? Int. Age is equal to 22. Okay. Harvey?
Gender.
Gender. Okay, this is an interesting one. Okay. What data type do we use for gender? Hold on. Before you say anything, gender can be represented by one letter, either M or F. So what data type can we use for this?
Boolean.
No, Boolean is only true or false.
No.
It only has one letter. Which data type did we mention only has one letter? Or one deals with one letter?
Not the one on the chart.
char. No, I'm gonna be male. Okay, got it?
Why is it called? Why is it quotation? Why is it not?
Single quotes. Single quotes.
Yeah.
Chars are single quotes.
Okay.
Remember? Chars have an entirely completely different set of functions versus strings, right? Strings have a completely different set of functions, and chars have a different set of functions. Ints have a different set of functions, right? Okay. Steve? Wait. Okay. Should it be?
No, double.
Double.
Give me like 1.5.
Okay. It's interesting because you guys have been choosing the exact same.
I've never measured myself 165 and a half.
You guys are choosing the exact same properties that the morning class shows. Okay, Nabiha, anything?
Hair color.
You guys are choosing the exact same thing. Okay. Okay, what would that be? What data type?
Black. Oh, straight.
String. Okay. Hair type or hair color rather, right? And we put black. Mine's black. Okay. And Daniela?
Height.
I think.
No.
Do we have height? We don't have height. Okay. This one is, you can do it a couple ways, right? What are let's have her answer. What data type can we use? Can we use? Notice I said can, right? We can have multiple, like, there's different possibilities here. What data type can we use to store the height? A double. Okay, if we put double, how would that work? If I'm 5'7", how would that be a double?
You use matrices.
Would I, huh?
Use matrices.
Is that right? So that is one that, yeah, so that's one way we can do it. We use centimeters, right? So private static double height, and we use the metric system, and I say I'm 160, which is in centimeters, or 160.0, or 160.5 maybe, I don't know, right? That's one way. What's the other way? What's the other way, Daniela? What do you think? What other data type could we use? Okay, we could use ints too, but then what if I'm 160.5 centimeters? So I don't know if int would work, right? How else could we store our height?
It would be a double.
We already said double.
Use string.
What do you think about string? Could we use string or no? Okay, why don't we try it? String height equal to 5'7". Works, right? So that would be our height, right? Even though it's a number, remember I said even if numbers can still be strings, right? As long as you wrap them in these double quotes. So there we have our initial properties. Now, whenever you create a new person, okay, they're gonna have that instance will have all of these properties, and all the properties will already have values, right? So what do you think we're gonna do next? Okay, well, so I just said we have now set the instance variables, the properties, right? So now if we were to create a person, instantiate a person,
You need methods. You have to do stuff, right?
right now let's not do the methods since we didn't learn methods yet. Okay. So let's go ahead and create a person. Okay. How do we create a person? Josue, can you tell me how to create a new person? We did it earlier. I'm not sure if you guys remember. Let's. It's a hint, right? That's how we created a new car. right? Let's do the exact same thing for creating a person. Okay?
Yeah.
Did everyone get that? Nabiha, did you get that?
Yeah.
Kind of? Okay, so it's like this. Right?
Would it be wrong to put this person instead of mine?
It doesn't matter, it's just a name. Okay? We can say like new person. Okay? Got it? Now, I just instantiated a new person called new person, right? That instance, right? Because we have these instance variables here, these instance variables follow the instance, right? So, this new person instance should have a property called name, and its value should be Michael. This new person should have an instance variable called age, and it should be the value 22, and so forth. Okay? So let's go ahead and check that this person, new person, has those properties. How do we access the properties of an instance?
Just call it any time, right?
Yeah, but how do I call it?
Name equals name.
If I wanted to print out the new person's name, how would I do that?
New person's
New person. How would I print out the name? Okay, system.out.print. Well, what would go inside the parentheses? What would I print? So let's go back to here. Okay. You see this? What did I say this was called? Dot notation, right? And I mentioned dot notation is how you access the properties and functions of an instance. Does that make sense? It's called dot notation because first I give the instance, right, here. And then I put a dot, right? And then from there, I have to put the name of the instance variable or the name of the function here. And that will return to me. If it's a method, then it will go ahead and execute the method called move within this instance class. Okay. Right? If I wanted to access the color attribute or color instance variable from the mycar instance, let's do that. But that wouldn't do anything, right? Because I'm not printing it, right? So let's go ahead. Does anyone get what I just said? The dot notation? So it would be this, right? My person dot, right? And then, oh, it's not my person, it's, so watch this. So system dot, you'll know you did it right when it auto-completes for you, watch. New person dot. Now, just by clicking dot, Eclipse gives me a list of suggestions that I can do, right? So I can choose, you see all of these right here? These are the ones that we defined, right? So why don't I go ahead and print the name here? Okay, that's it. That's all it takes to print the new person's name, right? Using dot notation, okay? You can see how dot notation is very important here, right? Dot notation. Okay, so let's go ahead and print that. And what the expected value is Michael. So print, compile, run, Michael. Right? Pretty cool, right? So behind the scenes here, when we ran this function here, or this new keyword, this is a special word here that actually creates a new person, right? We have just customized our own person. Does that make sense? Do you see how this works, how instance variables work? So how about I go ahead and create a second person. What's the flaw that you guys see? Yeah, it's going to be the exact same. So if I do this again, right? Instead of new person's name, I'm going to put second person's name. Okay? They're both Michael. So whenever I create a person, it's by default going to have the name Michael. It's going to, by default, have the age 22, gender male, weight 160.5, hair color black, height 5.7. So there's no room for, how do I create a person with the name, I don't know, Steve? Huh? Yeah, we can make a method.
You start a new scope.
Huh?
You start a new scope.
Scope? What does it have to do with scope?
Like, you start basically a new
Okay, but, well, whenever I create a new person, it's still going to give me the name Michael. And then I'd have to go and change it, right? But what if I want the name to be Steve to begin with, as soon as I create a new person?
You just make a stud. Like you can just declare it, but you don't initialize it.
But then, okay, so just declare it, but don't initialize it. So like that?
Equals like empty.
Okay, so if it's, okay, so let's make it empty then. Okay, let's make name empty and see what happens, okay? Let's run this program again.
Yeah,
What's the expected output?
You just print empty.
Well, it'll print the empty string, right? So this will just be an empty string, so nothing will print, right?
But you just make a line right before you print
That's it.
that like name equals blah, blah, blah.
Yeah, but here's the issue with that, is that I want the name to be set right when I create this person. I don't want to have to change the name after I create the person, right? Does that make sense? So what you're talking about is that I can do this. New person dot name is equal to Steve. I can do that. Okay? And that will update. Okay, so this is an important concept, right? So, that's not good. Here's an important concept, okay? The instance variable, okay. The static variable versus the instance variable. So in this scenario, what just happened was, let's look at what just happened on line 14. Okay, 14. So what I did is I created a new instance of the class person, right? So here's our blueprint, right? We have class person, right? This is our blueprint, right? And we went ahead and we did this, right? We called it what? My new person, right? Right, and there he is, okay? And he has all these properties, right? He says name is equal to this, height is equal to this, right? He has all of them. So if I ask new person, hey, what's your name? He already has it. Hey, what's your height? He already has it, right? And then we went ahead and we did this, right? Created another one down here. We said call it second person. Right? But he has the exact same qualification, same numbers as the first guy, right? But then we went ahead and we did this. On line 14, we said new person.name is equal to Steve, right? We're referring only to one instance, this instance. So we changed only his name to Steve, okay? Notice, when I said we changed the instance name, we didn't change the class value. Okay? The class value for name here still stands as Michael. Right? So when he did this new person.name is equal to Steve, okay? We changed the instance name. Okay? If I wanted to, how could I change the class value? How could I do that in the main method? So that was, I changed the instances property called name. How do I change this guy? To permanently change it now, right? If I permanently change it, that means that anytime I instantiate a person after that, it'll instantiate him with that